so this lesson is 12.5, surface area of rectangular and triangular prisms. Now, before we can do any of this, we need to think about what a prism is. So you need to write this definition, so press pause if you need to. A prism is a solid object with a uniform, now uniform means unchanging, top and bottom, and all sides are flat. Now they can be round flat. So if you think of like a tin of spaghetti, that would be a prism because the top and the bottom are the same shape. That is a circle. And even though it goes round, it is flat, okay? Another one would be a triangular prism, would be like a Toblerone chocolate bar, which has a triangle at one end and a matching triangle at the other end. Okay, so they are both examples of prisms. So in your book, I've said refer to page 442 for some examples. Now, in fact, I'll see if this is going to fit under here and find the page. You can have a look, of course, at your own page. Excuse me for a minute while I get it. Now, let's have a look. Let's see if you can see this. So, this is like the Toblerone bar because on the bottom is a triangle, it's matched with the same triangle on the top. And the shapes that are around the sides pull the triangle together. And they're flat. They're all flat. Okay. Now this is a rectangular prism because here's a rectangle on the bottom. Up the top is the same rectangle. And the sides are all flat. Here is a hexagonal prism. 1, 2, 3, 4, 5, 6 shapes. Sides on the bottom, exactly the same one at the top, and they're linked with flat surfaces around. Now you might hear the word cross section, and that's a cross section is like a way if you chopped any of these in half, like chop that, chop that, chop that, and as it shows in the picture, then each of these produces the same look. All right, so not the width of it here, but it is a triangle, 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 and that never changes. So what is not a prism? Because it's important for you to know that as well. These are not prisms, and let's have a look why. The cone has a circle on the top. Does it have a circle on the... a circle on the bottom. Does it have a matching circle on the top? No, it doesn't. The sphere doesn't have a bottom or a top, so it's not a prism. The square-based pyramid has a square on the bottom. Does it have a square on the top? No, so it's not a prism. And this is a triangular pyramid with a triangle on the bottom. Does it have a triangle on the top? No, it doesn't. So yet again, it's not a prism. So hopefully that helps you with what a prism is and what a prism is not. So we can say, why is a cone or a sphere or a pyramid not a prism? Let's say something in our own language that we can understand. So maybe we could write, because it does not have a matching top and bottom. Now, that is not mathematical at all, but it is hopefully a way that you will be able to remember what a prism is. Now, what is surface area? It's area of all the shapes on the outside added together, okay? So area of every shape on outside added together. Again, that's not a very good mathematical definition, but it's one that we can hopefully all understand. So how do we do this? Remember to press pause so you can draw this diagram. All right, so we have a rectangular prism, all right, because on the bottom we have a rectangle. So down here, and I'm going to label that number 1. And I'm going to draw it here. Now, you don't have to always draw these, but we're going to draw them to start with. Now, the length of that is 10 and the width is 5. And we have it on the bottom here, but hopefully you can see we also have it on the top up here. So we're going to do 10 times 5, but we have 2 of them. So we're going to multiply that by 2. Before we do any maths, let's have a look now at the ones on the end. So if we drew that one, not to scale, mind you, we have a 5 on the bottom, this here. Oh, sorry, and up the side we have a 6. And how many of those are there? There's one on this end, and there's one over here on this end. So, of course, we have 2 of them as well. Now, what do we have left? We've done the bottom and the top and the end and the end. So we have the front. Now it's getting difficult to see. So the front here. And, of course, we have the same one at the back as well. So now you got to think 3D and not get confused. So now we're thinking of the front of this box. So we have 10 along the bottom, and what is this here? Well, it's going to be the same as this, which is 6. And we have 2 of those. Okay, so now we can work out what we have all together. So we're going to have 10 times 5, which is 50, but there are 2 of them. So that means we have 100 centimetres squared, because we're talking about area. So we have done the bottom and the top. We have 4 more sides to go. So the ends, 5 times 6 is 30. We have 2 of those, so that is 60 centimetres squared. So now we have done bottom, top, 2 ends. Now we're up to the front and the back. And that is 10 by 6, which is 60. And we're going to multiply them by 2. So we have 120 centimetres for those 2. Now, we have to add all those together because the surface area is going to be when we add all of what we have. So we go 0, 0, 0, 0. 6 plus 2 is 8. And 1 plus 1 is 2. So our answer we're going to write TSA. And that stands for total surface area equals 280 centimetres. All right, so let's have a look at another one. This is exactly the same as what I've just done. So maybe you should have a go. And I'm going to do it too. And I'm not going to talk, so let's see if you can just do it by yourself. All right, see if you get 212. If you didn't, then have a look and do it. Have a look at my working out and see if you can understand what that says. Otherwise, come into the chat and let us know if you need some help. Okay, number 3 is a different shape. So this one is a triangle. So what that means is the base shape this time is a triangle. And I'm just going to draw it on the side a little bit, but hopefully you can still see that this triangle comes from the front, and we're going to have another one that's identical in the back, because that's what prisms are all about, having this same 2 sides shapes. All right, so on the side here I've got 3 and 12. And remembering, this is a little bit more difficult because we have to remember the side, the area of a triangle, work that out, and then we're going to have 2 of them. So hopefully you all remember that the area of a triangle is half times base times height. And then when you get that answer, that's for one triangle, but we've got 2. So we're going to multiply the answer by 2. So if we put that in, we're going to half times base is 12 times height is 3. And we have 2 of them. So then we're going to have 6 times 3 times 2, because I just did a half of 12 is 6, times 3 times 2. And we should get 36 centimetres squared. Now, you need to think about what it is that you found, okay? You found this and this. So now we're going to go along the bottom. And it does get a bit hard. We have to kind of use our... Oh, you know what's missing here for you guys? You need to know what this is. This is 13 centimetres. All right, so along the bottom is a big rectangle. And as I said, this is when it gets difficult because you've got to really be able to see this in a 3D way. Now, if you could sort of see what this is, it doesn't look like a nice rectangle, but if you could envisage that, you would know that it is a rectangle. And along this side, it's 13, and along this side, it's 10. Okay, so I'm doing the bottom here with a 13 and a 10. Now have a look. How many of these are there? Because normally we multiply by 2. This is 13 by 10. How many sides left are there? Well, there's the top one. What's that? No, that's 12 by 10. And then there's this back rectangle here. And that's going to be 3 by 10. So all the rest in these are in fact different ones. So we don't multiply it by 2 because there's only one of them. So this one's going to give us 130 centimetres squared when we do 13 by 10. All right, so we've done 2 ends and a flat bottom. So now I'm going to do this top wedge. Okay. So this top wedge, believe it or not, is also a rectangle with this side 12 and this length being 10. And there is only one of those, and 12 times 10 is 120 centimetres squared. All right, now there's one more side that we haven't done. And this is going to be this very back bit, which I'll do in black. Okay, so what have we got? We have a side length here of 3, and this one along the bottom is the same as this. So it's going to be 3 up the side, and it's going to be 10 along the bottom. And remember, there is only one of these as well. So that's going to be 30 centimetres squared. Now, if we add all those together, we get 1, 2, 16, I believe. Hopefully, let me double check. 6, 3, 9, 10, 11... 316, I think. 1, 2, 316, not 216. Hopefully you got 316 centimetres squared. All right, let's just have a look at one more, which is no new concept, just using it in a worded question. Okay, I want to paint a toy box. The dimensions are shown. I want to paint all the sides except the bottom. How many paint tins should I buy if each covers 30 metres squared? So first of all, I'm going to put them in brackets because you don't want to worry about that at the start. If you want to paint, then you're going to have to think about surface area. Okay, so let's see how many shapes we've got. We're going to have the front and the back, which are these little squares. And you will notice that these squares are in fact squares. So if this is 4.2, then this is 4.2. So we're going to say, I'm going to put a 1 in there, and that's a 1 as well. So we're going to go area 1 equals 4.2 times 4.2. Like, how do you work out the area of a square? You do length times width. But there's 2 of them, so when we're done, we're going to multiply that by 2. Now I need my calculator. Bear with me. Hopefully you've gone ahead and you've got the answer to this, because my calculator's not going to work. It's just not too handy. Come on, calculator. Okay, hang on guys, sorry. Alright, what did you get? You should all have done it way quicker than me. So, 4.2 times 4.2 times 2. Alright, so we should get for this area 35.28 meters squared. Alright, and that has taken care of how many sides? 2. The front, 4.2 times 4.2, but there's 2 of them, so we're going to double it. Alright, I'm going to put this side now. I'll do it a different colour. We're going to do this side length of the toy box because we want to paint that as well. And there's going to be another one of those over here. Oh, it does get confusing. Okay, you have to make sure you're following. So this side length here, it's going to be 6.8 along the bottom, and up here it's going to be 4.2. And how many are there? Can you see from the diagram? You have 1 on this side and 1 on that side. So it's going to be 4.2 times 6.8 multiplied by 2, because there are 2 of these sides. Okay, so 4.2 times 6.8 multiplied by 2 is 57.12 meters squared. Alright, now, normally we do 6 of these, but if we go to the question now, it says I want to paint all sides except the bottom. So we do not care about the area of the bottom. So let's have a look. The only thing that's left that we care about is the top. So our rectangle for the top, what is it going to be? So here, the smaller side is 4.2 here, and the length going back is 6.8. Now, why is that the same as the one we've just done? Because this is a square. So this length is the same as this, same as this, same as this. If you can see that ahead of time, you can do it that way. Okay, so we do 4.2 times 6.8, but we don't multiply it by 2 because we do not want to colour in or paint the bottom. So if you were to look at this as it is and say how many sides are there, you'd get 1 at the end, 2 at this other end, 3 from the side, 4 from the other side, 5 on top and 6 on the bottom. But we don't want to paint the bottom, so you should only come up with 5 sides. This is where this comes from, a 2, and this one is just 1 by itself. Alright, so we have 4.2 times 6.8, 28.56 meters squared. Alright, so they're all our individual ones. So we're going to now work out total surface area. So total surface area is going to be 35.28 plus 57.12 plus 28.56. All right, everybody put them in your calculator and see if you get what I get. All right, I'm just going to check that because I don't have you here with me saying, yep, you're right, or no, you've made a mistake. So I need to double check myself. Hopefully someone, oh, I got a different one. Oh, lucky I checked. Let's see which one was right. $120, look at that. See how right it is to check, everybody. 120.96 meters squared. All right, that's a big bulk of your question. But if we go now back to the brackets, how many paint tins should I buy if each tin covers about 30 meters squared? So, one tin will get us 30 square meters. So, if we buy 2 tins, we can cover 60 square meters. 3 tins will cover, I'm just going to add another 30, 120, and we're very close. I'm going to go cross out about. I'm going to change this question. How many paint tins should I buy if each tin covers 30 meters squared? If I buy 3 tins, am I going to have enough? No, I'm not. Just by 0.96 meters squared. How annoying is that? So your answer, and this is a trick question, if you buy 3 tins, you're not going to have enough. So you would actually have to waste some money and buy 4 tins would be enough. Sure, you'll have leftovers, but if you buy 3 tins, you're not going to have enough. All right, so the other way you could have done this is 120, if you get bigger numbers than this one day, is how much you need to cover divided by how much each tin will cover. So if you do this, you'll get 120.96 divided by 30, and your answer's 4.032, which means 3, 6, I've made a mistake again. So this is 90. 4 tins would be 120. You're all yelling at the video, aren't you? I've added 30, 60, 90, 120. Hopefully you go, why did you jump so far? I don't get it. So this would be 5 tins would be enough. And the reason I worked out that I made that mistake was because I did this bit. So it is probably worth doing both ways. Mistakes all over the place today. All right, so 120.96 divided by 30 is 4.03. It means you need 4.032 tins. So if you get 4, 4 will not be enough. Therefore, your answer is 5 tins. Okay, not 4 tins. Now, there is one in your, there's only a couple of worded problems, and there's one that I've set that is exactly the same as this, all right? So make sure you come back to this example that you've hopefully written as you should do because you're like you're in class. And the first thing you need to do is 12.5. Now, there's not a lot to do, so I really want you to do all of these. These are just one question, each of these. All right, so it looks like you've got about a dozen questions to do. Most of you are able to do them in like 20, 30 minutes, which is good for the whole period. And then I want you to start your measurement task, okay? I will give you the due date. If someone comes back and annoys me in class, you can let me know if I haven't already set it. All right, terrific. Please make sure you come and ask for clarification when you get to some of these ones which are harder to envisage, being 3D, or you just don't understand how they're done, because that's what we are here for. Okay, thank you.